we are with some more OCaml CLI calculator. Let's get it. So in the last video, because this is now the third video in the series, I finished the basic functionality. So for comparison, for those who are unacquainted, I made a calculator in Haskell, a command line calculator, just a simple stuff, 6+7. Zoom in here actually, like 6+7, and like just basic expressions, no variables, nothing. And in the last video, I just finished everything, basically rewriting it in OCaml, with everything. But I want to now expand it and do more. So just to get straight into it, let's open NeoVim, and I want to do at least two things before moving on to Rust, which is the next phase of this project, which is Jesus. I want to add variables, and I want to add functions. Now I don't know how far I'll get, but at least without losing my sanity. Obviously, it's possible, but I don't know how much I want to keep using OCaml, especially in yesterday's, was it yesterday? I can't remember now. I mean, I committed yesterday, but in the last video, I learned that OCaml is actually quite old because it's based on ML, and as a result, it has some very quirky features. Some are cool, quirky, and some are just a bit annoying, to be frank. So I'll see how far I get, but anyway, honestly, this shouldn't be too hard, I don't think. Yep. So let's just get straight into it. So I think I can. Okay, well, we start with the parser. No, okay, I have the evaluator twice here. We start with the tokenizer, of course, because we need to add more tokens for new things. So I could start with variables, or I could start with functions. I think I'm going to start with function. Are functions easier? Because it's like parsed it inside brackets and everything as well. I don't know. Tell you what, I'm just gonna do what makes sense in order. Cannot make changes, modify those off. What do you mean? Yeah, it's fine. I'm going to start with variables. So you've got a number operator. Yeah. So right now we only have 4 tokens, because there's only 4 things supported. We want to add a new token to start. So we can have a number operator, parentheses open or closed, or an identifier, I guess. Because I do wonder, like, with a tokenizer, you don't just like, you don't parse as you tokenize. Like, so you don't like differentiate between, okay, this is a function and this is a variable. Like, you kind of just say it's an identifier, and then you later from context figure out what it is in the parsing stage. That's my assumption. I could be completely wrong, but let's just go with this for now. Obviously, I could look at a tutorial right now, but I want to just see how far I can get without that. See how far my intuition can get me. So yeah, we got number operator, parentheses open close, and an identifier. For an identifier, we could either have assignment, like x equals 5, or we can have obviously use, so x plus 5, and then print that. So we're going to add a new operator. I'm going to go ahead and expand these now to their own lines, like so. To the boom. Yep. Okay. And we'll add a new one for equals. Right? The equal sign. The equals operator will be used for both assignment, and that's it actually, for just for assignment. I am thinking about adding. I could add Boolean operators as well, but that could come later. I don't know. But equals, as in the equal sign, and then if I were to add like another equals, I guess I'll do like double equals, like this. But I don't know. I could also, instead of using equals, I could do the arrow sign. I'm quite a fan of this for assignment because then it allows just the normal equals to be used like normally. and then obviously not equals, or in this language. Does this language have a not? Does this language have a not equals? I thought it was this, but maybe it's some context. Can I just write it somewhere else? Yeah, it is. Okay. Um, yeah. So I could use this and then reserve the equals operator for actual equality as opposed to assignment. And you know what? I think I will, because actually, um, on my graphing calculator. Sorry, I just realized my microphone's been like really far. Hopefully my voice hasn't been too quiet. On my graphing calculator, I literally have a storage symbol. So if I want to do, give me a second, 5 store, what's stow x. Let me see if I can show this here. Uh, here. How clear is that? Man, this camera's focus is just awful. Okay, it's really hard to see. How do I get it to focus? Like, I swear it's actually like, yeah, uh, uh. Whatever. Point in case, it's a 5 with a forward arrow into x. And that's how it works. So I'm doing the same thing, but just do it backwards. So let's do that. So screw it then. Instead of equals, we're going to do left arrow. Nice. And then that's an operator, and then we have our identifier. Okay, let's see how this works then. So we got, whoops, how, what do I press? Okay, close that. Okay, we're back, and we're back. Okay, so parse number, tokenize. Okay, yeah. So this is like the else condition. This goes by single chars. So you could have like an ahead. In fact, I think I can just match. Yeah, because I can match more than one char at a time because it's matching the whole input, isn't it? Yeah, that's fine. So in that case, I'll just do like this. I think I'll do like boom cons Cs, right? And then I would just token map that to a left arrow, right? On Cs. Okay, I believe this is correct. So if I compile this, I mean my tokenizer won't know what tokenizer. My tokenizer should work, but everything else should crash. But like as long as it recognizes this in tokenizer, let's test. So what's it called? OPAM June builds. It's gonna build its thing. Might give me an error, but hopefully not this early on. Okay. Such as then June execute bins bin/bin/min.exe. So let's do x. Okay, well, x will be an invalid token. Yeah. But let's say we do 5 store 3. Arrow cannot parse tokens. So we got operator tokenizer left arrow and 3. Okay. Arrow cannot parse tokens. Nice. Okay. So I think it worked. Except I need verbose output. So let me close this and do this again, but with a flag. So again, 5, boom, boom. Okay, so as you can see, we've got our tokens here. We have our number 5, the operator left arrow, and 3. Perfect. I mean, so like, I already kind of knew, like, I already kind of knew that the tokenizer would be the easy part. But then here, invalid token. So if it's not a number, then I think we do when. Is it? Or do I need to, or can I do like multiple rows? I guess this works for now. So we'll do is identifier. Right, so let is identifier. Yeah, this checks if the C is a digit. We need to check if the whole thing is like. So how do I do this then? I guess I'll do this. So I'll just take C's and then I'll pass in C's. So when is identifier C's, and then what is identifier do? Will do is just scan until the end of until the next white space character, and then just check if each of the characters are valid identifier symbols, and we're gonna just allow any English or any Latin letter, right? A B C D E F G etc. Lowercase and uppercase, unless I want to only allow lowercase symbols, and then reserve uppercase for functions. Is that worth it? Because that does kind of simplify the process, doesn't it? Oh, you know what? It's an interesting idea. So I'm actually going to only allow lowercase starting letters, and then the rest will be fine. So yeah, anyway. But if it is an identifier, then we just do let um wait, where's parse nums there? Okay. Um what are we returning for this function? We're returning a result with either a token list or a string. Parse num returns the number and then the rest of the string. So likewise, we want to return identifier and remaining from parse identifier. I mean, if we've already confirmed it is an identifier, then we kind of just need to read the word. So we'll just do read word from C's in, and then we use token map because with our token dot identifier, not invalid identifier. This there identifier pattern not found. That's strange. Have I made a mistake? Number float operator. Nope. Identifier should be fine, but okay. We'll see if that bugs later. Don't even need this then, actually. And then remaining. Okay. Pretty cool. So then we just need to write two functions, is identifier and um, read word, right? Read word takes characters, so we sees char list, and just returns a tuple of the identifier. So char list again, I think makes sense. Or we can do a string actually. Should I do a string? In fact, I need to do a string because this will be a string. So yeah, yeah, okay, makes sense. So identifier here, nice, and then yeah, so char list, no, well yes, but not there. String or and char list again, like this funky product type syntax. Okay, that's that. And then for it's identifier, it's like again C's, which is char list, and just return a bool. And we'll just do. Ooh, okay. So for this one, I need to use a filter. Well, I mean, in Haskell, I would think this should just do like filter and then an anonymous function. So kind of just don't remember how anonymous function as if I think it's fun like this. Function x to yeah. So for C, we just check is C mem. So mem I think is called C ooh. I don't think OCaml has this kind of syntax completion, does it? Okay. Let's go to Claude here. How do I declare a list range? Like I would do, for example, we'll do 0 to 9 in Haskell. See, I almost wonder if I should have gone back to Haskell, but I'm gonna push myself to really learn OCaml. OCaml, there might be list in it. Okay. List init nf produces a list of length n where the element I is fi. Okay, so you can just apply a function. If you want a general range function like Haskell, start to end. Okay. So I guess I'll just do this. So let's let valid chars equals, was it list dot init, how many, I don't know how many there are, 26 I guess, letters, and then would the function just be like, because I'm guessing I is the index, so like 0 1 2 3 4 5 to 25 in this case, so it'd be function I with a plus I, assuming that this is even valid. Maybe it's not though, so we'll have to fix it later. I do need parentheses, just checking, and in, and then just replace that here. So valid chars. But before that, ooh, can I do early returns? Can I do early returns? Because like I want to check if the first thing sees is even valid in the first place, and if it's not, then just disregard this stuff. Um, I guess I can do this for now as just if head of C's, how do I get C's? Like, I mean, I guess I do C's dot 0. Should be fine. If C's dot 0 equals actually okay, no, I can do it. I can't speak. I guess I do need this. So if, okay, fine. Like this, lowercase chars. So if C's dot 0 equals, no, if mem, so this is a member of lowercase chars, then, or rather if it's not, how do I do not? Yeah. How do I do not in OCaml for a Boolean expression? Because I know the, huh? Oh, it's function cool. Okay. Because I know the exclamation mark is reserved for dereferencing references or whatever. Oh, okay. Oh yeah, dereferencing. Not true is false. No, okay. So I'll wrap it in like this. So it's not. Then we want to return early. So actually, I'll put it here then. Then false. Yep. Else, and then we have this, right? Or maybe what was cleaner? What's cleaner? I guess like this is fine. Else filter. Yeah. So now we need to define another one, which is uppercase chars equals list.init 26 again. But this time from A with capital. I assume this is ASCII, but even in Unicode should be fine. But whatever. Yep. And then we need to filter through these. So how do I combine two lists? Because in Haskell, I just use the plus plus operator, but how do I combine two lists? Or I could just, instead of combining them, I guess I could just check them individually, but at sign. Or list will depend. Okay, sure. Yes, another use of the at sign not being used for anything like at. So valid chars, nope, it's called lowercase chars and uppercase chars. Yep. Okay. Filter this C's, right? Yep. And I could add underscore, but I don't want to support that. Yep. So I just but like if you want to have full names, should I enforce camel case? Okay then, I'll include this, but disallow the first char from being that. So like this, I think should be fine. I don't know how many of these brackets I need, so I'll just ignore. I'll just avoid them for now. Um. Okay, but also I have an issue. I need to first read the word. So I kind of reading the word twice, but this should be okay. Ooh. Or is it? Uh, 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 doesn't OCaml have for loops anyway? Anyway, read word. Okay, yeah, I need a string. Okay, let me implement this first, actually. Yep. So for read word, we just do take while. Would it be it? So like just take while. Um, oh, well. I mean, in Haskell, I'll do take while. Um, but we have to be like this, right? C's C does not equal a space on C's, and then um, same thing, but just drop while. Oh, there's two. Same thing, then just drop while instead, like so. I don't know if that has the note. So OCaml, does OCaml have an equivalent of Haskell's take while and drop while? Yeah, just caveats. Okay, just on the version. Okay, well I am the latest version, so take while and drop while. Oh, whoopsie daisy. So take while is just list dot take while, and drop while is just list dot drop while. Okay, and how does it actually implement it? If f(x) then x colon to take while f(x) else. Okay, interesting. And I use filter, I think, here. I don't know why I use filter. That should be fold. Um, let's see how that works. But so this should work fine. Except then I also need to list dot to string, I think. Or string dot of sequa for sequence. Okay. Um, and to make it a bit cleaner, I'll just say let word equals this part, and then let rest equals this part in sorry, this is not correct. Boom, boom, boom. In word rest. Okay. Yeah. Nice. I just realized my thing is covering the bottom. We don't like to do that here. Okay, I need to actually confirm. Yeah, I'm above it. Okay. Nice. Just so you can see me doing the keybinds if that interests people, or is important to people. And yeah, that should be fine. So then for here, uh, does OCaml have an equivalent of Haskell's folder or foldel or foldel prime to be exact? Yes, fold right, fold left are direct equivalences. Okay. The main gotcha is that fold right's list and init being swapped. Fold left is tail recursive, fold right is not. Same trade-off as in Haskell. So that means that fold left is more optimal, right? Because I can't remember. So the fold left is more efficient. Yep. Yep. Okay. Um. So I'll need to define our string and then convert it back to a sequence. I don't know if I like that though. I think I'll just take this because I don't need the rest in this case. So I'll just copy this as a function here. Um, let's. My God. Actually, not script. Code duplication. So we'll just yank this and say let word equals this. Somehow I failed to copy the right thing. Yi in brackets, please. Okay. In, and then we're not doing C's, we're doing just word because we don't want everything. And this would be list dot fold left because the order doesn't matter in this case. Okay. And that would be false, false, false. I have an accumulator, so fold left is B to A to B, where B is the accumulator. Okay, so accumulator and C. So let's just be accumulator and, right? Because we want all of them to be true. Yep, that should be working. Okay, let's just build and let's build and see what that does then. Oh, I thought I could do dot zero to get the index now. How do I get the head of a list? Should just be dot list.hd. Empty list on failure. Well, in this case, it should be an empty list. That should be impossible. So, all right. So use parentheses again. List.head. Why is it HD? Like of all the things to abbreviate. Um, yeah, should be okay. See what else there is. This expression is type char list, but an expression was expression of type char sequence equal unit to char sequence node. What? I'm guessing because I'm calling a string of sequence, right? Did I just mess it up? Just the wrong one. List.toSequence, string.toSequence. List.ofSequence, string.toSequence. So do I use list.ofSequence? My God, these names, man. No. It wants a sequence. Huh? It wants a unit to a sequence of node. Am I tripping? Am I missing something? This only has one argument. Yeah, string is string of sequence. So it takes a list that is a sequence and it converts it. Yeah. So what am I doing wrong here? This returns lists will take a while to return a list. It has a type of char list, so that's fine. That's what I was thinking it is, right? But it wants a char sec.t equal unit to char sec.node. Huh? Okay, I need this to be broken down for me. What does this error mean? Give it as little context as possible. No man. Start traces too, but list to take a while in terms of char list. Oh, am I using a sequence.t? I thought I was using a list. Am I not? Do I have to like use of list or something? You just convert it to a sequence first, or with a pipeline. Yeah, I'm not using a pipe operators for this one. Use this for structural inequality in OCaml. Oh, that's right. Wait, so there was not equals. Physical pointer inequality. Okay. I love how completely different the symbols are. Like this means C does not equal this. Like, what are we doing? Um, that's right. Yeah, I mean, like literally down here, I do the same thing. I convert it to sequence. In fact, I literally use let's all take a while here. So I forgot. Okay then. Um, fine. So then maybe do list dot to sequence, or is it off sequence? I can't remember now. List dot to sequence. Yeah. Okay. Just need to fill this in. Right. The constant a has type char, but an expression is associated with type int. Yeah. So how do I increment? How do I do a +1 properly? I mean, obviously in C it's just really easy, but OCaml must use some different logic. In OCaml, char and int are strictly separate. Use char.chr and char.code. Okay, so I need to like convert forward and back. Converts char to its ASCII int, converts int back to char. Did I do +1? No, plus I. Okay. So I need to do so I need to first convert it. So char.code. So it'll be char.chr because that's abbreviated for some reason. And then char.code. So get the code, add one, and then yeah. I generate the brackets. Good. Okay. Same as Haskell, to be fair. Line 28. This might be unmatched. Let's just forget. Oh, same line. Because that's the end of the function. Bada bing, bada bong. Mem, unbound value mem. I think it's supposed to be list.mem, actually. Whoops. List.mem for member. Okay. The constant A, yep, that's right, same thing here. So I'll just copy this. The whole thing, really. Boom, boom, boom. Bam, 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 beam. Do bow. Okay. Line 33, the value word is type char list. Expected type bool, that's right, it's a fold. So we need an initial value, which will be true. And then unbound constructor identifier. Did you mean token dot identifier? Ah, I was wondering why it didn't recognize it. Because I made a typo. But that's a good sign, I guess. That means that it works. So is that it then? It actually just recognizes it now. So if I do x boom boom 5. Yeah, wow. Okay, so we got our identifier x, left arrow, and then 5. And then of course the parser doesn't know what to do, but nice. So how about like foo first of all 5? Yep, takes foo bar. Nice, foo bar. Nice. But if I do foo with a capital letter, that should be invalid. Yep. And if I do underscore foo, that should also be invalid. Perfect. Yo, I love this. This is so fun. So cool. Our tokenizer is finished, I guess. Let me also try seeing it the other use case. So if I have 5 plus x, yep, 5 plus, and then it reads an identifier x. Nice. And then of course I can't do like 5. How about 5 plus x like this actually, or 5 plus x plus 3? Okay, so this is an issue. Right now I'm only taking the word, but I should also stop if I get to just a non. Really, if I get to a non-matching character anyway. Also, I made a mistake. I need to allow numbers as well. So this is getting quite messy already. But let's do. So we got our uppercase characters. Let's do let numbers equals list on it. This should just be the numbers 10. Numbers 0 to 9, sorry, which is 10 different digits. So function I to I. Yep. That's it. We'll say let valid chars, and then we'll take this. Yep. I like that. I like that this works. By the way, at sign numbers in, and then we can replace this. Not that. Let's replace this with. Not even like this. Just this. But nope. This with valid chars. Yeah. That's fault left. So the word is take while. Whoops. But this should, instead of this, it should be not list dot member C and valid chars. Yeah. So let's see if that compiles. Doesn't. At numbers, the value numbers is type into list. That is correct. I need to actually convert this to a char. How do I convert an into a char? How do no? How do I convert? Um, how do I read an int as a char? I.e., 1, 2. Sorry, the other way around. I could. I mean, I could just run a custom function, but maybe there's a maybe there's an existing thing. Code plus char code dot. Oh boy. So there's no built-in thing. Yeah, it's a bit annoying, but it's fine. So we'll do let digit to char, right? Which takes a digit. So int or a x int to c char. Sorry, and it's going to be pretty simple. I could patch and match it, but I'll do the thing where you convert it. So char char.code of 0 plus x. I don't know what the order is. Hold on. That can actually fit on one line. What's the order here? I think it goes 0, 1, 2, 3, 4, 5, 6, 7, 9. Is that correct? Or is it 0 at the end? Okay, can we not do this, chat? No, it's fine. Okay, so 0 is first. That's fine. Um, we'll change x to n. Uh, because it's a number. Okay, so then we just do digit char. Here, and that should be fine. It's safe because it's just does that. Nice. So now if I do foo3 equals not equals assigned to 5. Foo3 is a valid identifier, but I can't do 3 foo. This will probably be parsed as 3 then foo. Yeah, it does. Is that good or bad? I mean, it'll fail on the parser anyway, so it's fine. But like, yeah. So I mean, I can't think how I would solve this otherwise. Without, well, I mean, obviously I can, but like, it would just be kind of a pain in the ass. So now I can do foo3 plus 5, and that treats it as an identifier. Oh boy. Okay. Yeah, I said if it's not a valid char. So plus is not a valid char. So it should take while. Um. Huh? Okay. Words, yeah, that's fine. C, that's fine. Is this backwards? Should this be take while it is a valid char? So not. Okay. To quit and again. So let's do the save. No, was it foo3 plus 5? That's weird. Why is it doing that? And also, what the hell? 5 plus 3, fine. Foo3, foo assign 3 with no spaces. Choose it as one word. Okay, that's not good. Clearly, so yeah, clearly it's not taking the word properly. Did I save it? I did. I did. Um, this seems sound. Valid chars doesn't include other stuff. Yeah, I'm confused here. Let me print valid chars. Question is how do I even do that? Um, it's a char sequence, so print and line. String dot of sequence of string list dot to sequence of valid chars. That's like the fastest way I can think to do it. If that even compiles, I don't know if that's allowed. It is allowed. Nice debugging OP. So this. Yeah, it accepts ABCDC, blah, 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 ABCD, blah, 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 and then just 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so that's expected. Um, so why is it combining this? This is identifier. Oh, because I didn't change this, did I? Yeah. So let me change this then to parse identifier. Okay. And then I'll need to make this as well. So let's valid identifier chars, which is just a char list equals, and then we'll just copy all this logic. We have lowercase and uppercase, and yeah, like so. Delete this. We're just going to return this. So boom, 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 boom. Don't need this either. We don't do this. We just need this. Yep. Yep. And then for let's move this up, or at least try to. I'll just delete it. I think that's better for the syntax for the formatter. Okay, and then this uses parse identifier, right? I mean, I can use it here, but yeah. So I think I could just do, because that's not needed anymore. That's known. And then for let word, I can just do parse identifier. So CTI. Let's do this. Yep. So just do let word equals parse identifier of C's, and that'd be fine. And then for valid chars, this would be valid identifier chars, right? So let's just yank that and paste it here. Okay. And likewise here. We want this logic here, this function. Okay. So let char list equal uh, this, or where are we? Sorry, char list is list dot take while this function of C's in this. So CA boom, no, CI boom, no, it was actually CA boom, char list. Okay. Yep. Oh, control Z resets. Good to know. Yeah, that's not too bad. Like. Um. Okay. Yeah. Right. So let word equals this, and then just pull left on the word. Sounds good to me. Or looks good to me rather. That's fine. This should work now, except I also need to change this. Do I? Parse identifier. Okay, that should work. Just exit. This is a char unbound value, so I need to move the definition somewhere else. I have it here. Let's put it above. Not the most organized file, but whatever. Line 28. Whoops. I had. I chose the wrong one. Should we C and then just this? Yep. 38. Value has type string char list. What are we on about? True word. Word is a string. Right. So I'll just do list dot of sequence. What the hell? Yeah. I lied. It should be string dot of sequence, I think, or string dot to sequence even. Okay, whatever. So let's type string char list. All right. All right, because it returns both. Um. Ooh, in that case. Okay, that's fine. I'll just copy this then. Yeah, just copy this. How did I get down there? What the hell? Yep. So yank that, and then just do this. Should be fine. Yep, looks good. Okay, so now if we do foo 3, 5, that should be separated. Almost. This just ends the rest of it. Why is that? What does remaining do? It does check this. Scheiße. Okay, in that case, we need to check let condition equal the inside of this function. Actually, just this even. Well, I could make it a function. No, I can't make it a function. Ooh, I could make it a function. If I do like function application. Something. Forget it. Right, so we got this. Yep. Condition takes a C. Okay. So just condition C. Terrible naming convention, but I can revisit this later. And then not condition C. Yep. That should be fine. Oh yeah. So now it should work. Through 3, 5. Oh. Also looks like a crash. That works. That's like stuck. Why is it getting stuck? Why is that happening? List.mem. By the way, this is concerning. My laptop battery is like at 99%. Hopefully, like it's yeah. Anyway, um, why did we go forever? Take while it matches the condition. Drop while it doesn't match the condition. But it shouldn't go infinitely, because it should reach. If it reaches the end of the input, it should just exit. So this is strange. I'm not sure why it's getting stuck. Hmm. And it's just not getting stuck, and it's just really slow. But like, why would that be the case? Yeah, my fans are going off, so clearly it's overflowing somehow. Um, how bizarre. This is annoying me. Let mem C take while function C's condition C. Function C not condition C. Drop while. Drop while it does or doesn't match condition. It would be the opposite, right? So drop while it's like any other character, which can include yeah, it's just not a list member. C valid identifier chars. Uh-huh. How's it getting stuck? This is really strange. I'm actually a bit confused. An infinite loop somehow, which makes me think like obviously recursion, but where? And like all I changed was this, so why would that be the cause? Parse identifier, yeah, take the remaining. That looks completely fine. Generally have no idea. Okay. Right, let's ask Claude. our virtual assistant. Am I missing something here? Something about this. I change my code to this, and now I have an infinite. Well, now I seemingly have some infinite loop of sorts. It looks sound to me. The bug's in rest. The bug's in rest. Let rest equal drop while function C, not condition C, sees. What? Drop while it's not. Yeah, because we want to remove. Oh! Aye, aye, aye. Okay, so it's the same. It's the same. It's the same, it's the same, it's the same. Okay, so in this case, we can actually condense this into just condition. Yeah, which should look like this. Okay. So again, foo3, foo3, boom, boom, 5. Nice! Now it separates them. Perfect! Or foo3 space, boom, boom, 5. Foo3, boom, 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 boom. Nice. Foo3 plus 2, x plus 5, 5 plus x. Perfect. Okay, looks like that is all good now. So it looks like we've finished with our tokenizer. Now for the hard part, the parser. I feel like the evaluator shouldn't be too hard because we just need to track, like store it like in a hash map or whatever. But this is going to be a bit harder. The evaluator stage, parser stage. Sorry. Okay. Okay. So in our expression, we have a binary operator, unary operator, and number. I guess the question is actually, do I parse the expression and substitute it as a number in the expression, or do I? Surely I do it in the evaluation stage, right? Because I try to like, I could like, I mean, like, I'm trying to think like how. Hmm. I guess either works. Like with my evaluator, which is here, here, here. With my evaluator, I'd be adding an identifier thing here, and then it just substitutes it. Um, I guess for simplicity's sake, I'll just put it in the evaluator. It doesn't matter too much, so I'll just like since my expression is already code is like it's already quite not like super like I mean yeah complex. It's quite complex. Like it's hard to visually parse. Then I'll just try to separate as much as I can into the evaluator. It's like I mean I could technically evaluate it anyway, like during the parsing stage, but I assume the reason we don't do that usually is because that's not very patient. The downside is that I am passing a string through. So perhaps what I want to do instead is instead of storing a string identifier, I store it as an index to a hash map. So I think I'm gonna do that now because I can. So how do I do this then? I need to have it defined somewhere. Probably in the evaluator code. Uh, we've got the evaluator partition tokenizer, or I can make a new module, or like a new file, I guess, for tracking variables. That's great for now. Since evaluator is pretty empty anyway, I'll just put it in here for now. So how do we do this? I want a hash map. Well, do I want a hash map even? I can't. And hash map isn't indexed, so I can't store that. Unless I have like a hash map with indices, and then those point to an array of integer or sorry float values, right? Rather than having, is that efficient though? It's more efficient because it means I can pass in indices, and then I'm also like accessing the map less often. Um, but it's bad because then I have two data structures. But I think we care more about speed than we care about size. Um, in this case, it's interesting. Unless I'm missing something. Hash map to an index to an array, or a hash map to a straight value, with the downside being that you have to pass keys. Or can you, if it's a hash map, can I just pass the key, the hashed key, instead, and look up by key? Okay, let me ask Claude about this because I don't know enough. I am 1 week left for 2,000 research outside the hours of blah, blah, blah. What? Okay, let me actually just relaunch this real quick. See what's new in Claude. Give it a sec. Is it even going to relaunch, or do I need to do it myself? Seems to be doing its thing. Oh, just closed. Okay. And we're back. Downloading update. Why'd you do that? Why not? Why do I need to close it just for you to download it when I opened you again? Okay. I was hoping for like a UI change or something. What? Updated. So I need to launch it twice? Bro? By the way, yeah, so if I can pass a key, that's obviously fine. Because like same shit. Um but otherwise an array makes sense. Because then like every time I want to access the variable, I just access an index to an array, which is O1 lookup, I think. Whereas with the hash map, what is the hash map? And hash map lookup time complexity. Is it O of n? Is O1 an average? Average. It's not necessarily O(n) for populations. The typical entire time complexity for okay, fine. Um, but the bigger issue is that I'll be passing a string as a key. So the question is, can I avoid passing strings? That's a real question. So I have this. So I have this idea for a more efficient hash map lookup scheme where I store the values in an indexed array and then store the indices to the array elements in. Actually, this would also mean that I can point to. I can have pointers, so I can have like the same variables pointing to the same, like same identifiers, identifiers pointing to the same value, which is useful for pointers. But you know, in that case, I think I'm just gonna do that, right? Yeah, I'm just gonna do that. Whether or not it's the most efficient, for this purpose, for general purpose with pointers, it actually would be useful, and it also means, and yeah, screw it, why not? So how do I do this? I need to define a hash map. So, ooh, I'll put it above. So let's variable map, right? Or like these variables equal the ref. No. Um. like this. Ref map. Maybe. How do I create a hash map in OCaml? OCaml is a library hash table. Whoa. Let table equals hash table create. Okay, so I don't need to define it as ref, which is kind of nice. It is mutable, closer to data.hashtable in Haskell, not the immutable data.hash map. Sure. Immutable is different. Okay. Initial capacity. Can I increase the capacity? Surely. All right, let's use this as a reference then. So don't need this. It's hash table. Assume with a capital T. For some reason, it's not with a capital T. Dot create. 0. I mean, I don't know. I don't know what the I don't know what the capacity will be. I guess I can add some constants, can't I? Like pi and stuff. How should I do that? Just type it out, I guess. It means like you can't like E is reserved and so on, but that's not good because like there are constants and variables and those are different. So for now, let's skip the constants and just do this to start with. So let variables equals this. Yeah, that's actually pretty much it. So then for here, I need to identifier of int for index, and then we have an array, right? So we have our variables or variable pointers or even handles, I guess is a better name for it because it's like yeah. And then let variables equal an array. Not a list, not a linked list, an array, a vector. How do I create a dynamic array? Yeah, the bad thing is that if I want to add a new declare a new variable, I need to both I need to reallocate on both the hash map of hash table and the array, but oh well. Buffer for writing strings or array plus my own times. Okay. Array fixed size. Oh, camel arrays are not resizable. You'd have to allocate a new one manually. No one does this. The standard go is a down array or the widely used CC vector from the containers library. Okay. Why would I not just use? Okay, so it thinks. Yeah, it keeps on asking if I want go camel 5.2. Let me just add this to my instructions. I'm more or less on the latest version of OCaml and don't really care about legacy code features. Yeah, that's happened a few times. So dyn array, just create an empty thing. Okay, so variables just be a dyn array with no capital A for some reason. Dot create, boom, boom. Nice. Let's put these next to each other, I guess. Cool. So then, yep, we have ints there, and if we have an identifier, then we get the identifier. For the hash map, we need to first thing. Well, okay, well mm, we need to check it. We need to check if it exists, right? So how do I check if it's contained in the hash map or hash table? Sorry. Find table key. Raise is not found if missing. That's great. Returns option, prefer this. Okay, how about like just if it does exist? What's the method for checking if a key exists? Oh, makes sense. So if hash table.mem is it the key first? Identifier. Hold on. What's the do I need to specify the type, or can I just infer it? Do I not need to specify the type of the hash table? It infers it. Yeah, I would like to make it explicit, please. I'm not a fan of these. Yeah, I'm not the biggest fan of what do you call it? Type inference like this. Like at least like if I'm going to create it, I don't want to have to then infer the type from its usage later on. I only like type inference if it's obvious from the same line or previous lines. Because I like I don't want to have to like then think like add this thing to my mind of okay now I need as the reader need to infer what the type is. Like I don't like that. So it's a string and there's an int. Um, what's wrong? Is it not? Is it times or something? All right. Ah, okay. Ah, yeah. So it's to be like this. And hash table dot. What is it? Table? No, it's t, of course. And then just remove this. Likewise, this is a float dynarray.t. I assume that's how you do that. Okay. So if hashtable.mem identifier variable pointers, I could just call it a variable table, but whatever. Then, so if it is a member, then we'll to update it. So how do I do this? Replace hash table dot replace identifier. Oh, that's right. So I need to get the list here. So the index change. No, the index is the same. That's right. So I don't. Yeah, I don't replace it. I don't replace anything. I don't replace anything in the hash table. I just look it up. So I would use what? Find, look up. No, iterate. Okay, must be find. Yeah. So then hash table variables. My God, how do I get the? How do I replace? At last get push get. Okay, I'm going with dynarray. How do I replace an existing entry or the value at an existing entry? Set. Right. So dynarray dot set uh, value index new value. What's v? The array. Okay, I guess I can't do this then. So oh, this is for array lookup. That's right, not for list lookup. That's why I have to do head on list instead of dot zero. Okay. Or maybe I choose brackets and I'm just stupid. Okay, fine. So v must be the vector. V for vector. Okay. So variables, and then it was the index. So that's going to be hash table dot lookup find. Was it? Yeah. Find the table variable pointers. Uh, identifier. Set this to to nothing. Oh, yeah. No, sorry, I'm wrong. So I don't give this a variable yet. This comes later. Scheiße. Whatever. So if hash table member identifier. So if it is already a member, then do nothing. If it isn't, do nothing. You know what? Yeah, no, I don't do anything here, do I? Yeah, I don't do anything here at all. In fact, I don't do anything with that at all until I get to the parsing stage, right? Okay, let's just touch base here. Token map. What's wrong? The value identifier is type string, but an expression was expected of type int. Oh, that's why, because I want to pass it. Well, no, I mean this is the tokenizer, so I do actually want a string in this case. That's fine, right? Right? Like, I mean, like, yeah, like it's no different. But no, but like I want to add it to the list. You know what? No, 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 no. I was correct. 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 Okay. No, no, no. So if it is in there, then we get the index. If it's not in there, then we add the index. So we're not doing sets. We're doing just this. Just get the index. So be this token um like let's index equal. Here we go. Yep. Else hash. Yeah. Yeah. So if it is there, then we just get it. If it's not there, we need to create it. So that would be obviously the issue is then that like it will create variables even if the other stages fail. But that's not really an issue, is it? I guess it is an issue. Man, this is quite deep. All this to avoid passing strings. But then, like, do I avoid passing strings or do I avoid having just useless variable declarations? Like, it's fine. It's better. Like, it's better to do this method with handles from the tokenizing stage, if the if we trust that the programmer is smart. Um, let me just like. But if the programmer makes typos, and not smart, but like like not prone to making typos. But if they do make typos, then you, if there's no, but if you make a typo, either way, it's gonna have to. Yeah, no, it's fine. If, the the only way it fails is if it's ooh yeah. But the thing is, okay, no, 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 because I need to know if it's declaring. If it's not declaring the variable, I shouldn't create it. Yeah, okay. So nope, we are going to in fact leave this for the later stage. So remove this and change this back to a string. So we are passing strings, but it's kind of unavoidable. So then with our expression evaluator, let's just touch base again. Oh boy. In my evaluator, here's an example of a case that is not matched identifier. Because then I add it to my expression. Yeah. Okay. So this is a so the tree will know if it's an assignment or not. Right? It's saying do this, do this, do this, do this, do this. Now at this stage I could you know what? A very important quote: code first, optimize later. So screw it. We're going to do strings. We need to add a new binary operator, which will be the assign operator, and I'm also just going to open this up two separate lines. Do I? Yeah, like should I indent this backwards? I could totally just do a macro for this or whatever it's called. Boom, 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 and then bump up. That was definitely unnecessary. And then yeah. So assignment should be the highest, the lowest priority, right? Like you do that after everything else. Um, so like if we think of our ped mass, it will be ped massa, where the last A is for assignment. Because we do assignments last. Yes. Okay. So I didn't leave comments for what I have here. I mean, I don't need to because it's kind of, I guess it's self-evident. Like here's our asterisk, here's the operator, the slash, and here's the base case, and here's a plus, here's minus. But I like comments just for readability. What is this? Yes, my favorite comment style. So level 3 is ped mass, so it'll be parentheses, um, negative numbers, which is negatives, and numbers, like yeah, literals. Okay, I mean I can call it numbers. That's fine. And then this, I mean, and later I'll put functions up there too. Here we've got, unless I want to do lazy evaluation, I guess, for functions, in which case I would actually, well, no, because that just means that for functions, I don't evaluate them fully. I just expand them. Yeah, I mean, I'll think about that later, obviously. Um, that's not the right one. I guess it is actually. So parse L2, level 2. We've got addition, no, multiplication and division. That's it. And I'll actually level 2, layer 2. This is layer 3. And then layer 1 is addition and subtraction. But now I need another layer, which is layer 0. Um, do I even like these names? Like layer 3, like I know it's conventional. Layer 3, priority 3, higher priority means done first. Like it's done last, I guess. Okay. Yeah, so I'll add to layer 0. I can't have addition and assignment be the same level, so this would be layer 0, which is assignment. Assignment. Yeah, I love these comments, dude, so much. Like just having them in brackets is just so like nice for my human brain. So we'll do and parse L0, which same as anything else, just takes a token list, tokenizer dot token dot t, turns a parse result like everything else. Okay, it's not really helping. Equals let parsed equals parse level 1 tokens in parse L0 rest parsed. And yep, that'll be here. So parse L0 rest takes an expression t and a tokenizer dot token dot t. It's a tuple. Parse results, and we just match it directly. Okay. So left, it takes a tuple. So the tuple is the expression on the left, and then the rest of the token list. So in this case, the expression on the left we would expect to be a what do you call it? Identifier, right? Yeah. I think. Like for these ones, for these ones, okay. Well, I'll go to the highest level here. Parentheses open on tokens, minus on tokens, number on tokens. Left is an expression. An expression is one of these. Yeah. So I do match the identifier directly, because it can only work if the left side is a single identifier. So we'll do identifier. Well, do I need to? Yeah, do I even need this, or like, can I just do this? I guess I'll just leave the namespace for now. It doesn't matter. So expression dot took identifier, which has a string, so it'll be identifier, right? And then it'll be on the other side tokenizer dot right side even. Should be okay actually. I think. We'll see. Right onto. Oh, but no, these are tokens, so they haven't been parsed yet. What token am I looking for? Yeah. Sorry. I've got the identifier there. Then here I've got tokenizer dot token dot operator, and specifically the left arrow, right? And then onto tokens. Okay, very long thing there, but it's fine. Let's. I just realized by my own logic I should have these as well, but like this. Oh no, because the function is again implicit. Okay, don't ask. Don't ask. Okay, so let's Sufficient rest, right? Same as the other ones, I think. But we're doing parse L1 tokens instead. In parse L0 rest, recursive call here, expression dot binary op. Yes. Yes, okay. Um, Identifier on the left, which is fine because the binary operator takes a here, sorry, takes a t, yeah, that's fine. So identifier then the actual operator we want, so that would be assignment or assign even, and then expression. Yes. And then rest. Oh boy. And then we add the base case. So left tokens, just okay. Left tokens. Okay, I think that's correct. Let's see how far this gets us. Oh yeah, it's a sign. Okay, that was correct. Right, so I expect an error here to occur in the evaluator now, like a non-exhaustive error. No luck. The value identifier has type string, but an expression was expected of type expression not t. Is it type string? You're right, because I'm unwrapping it here. Whoopsie daisy. Shit. And I'm matching it like this. Okay, in that case I'll just do ID. That's kind of what ID stands for, right? And then just do expression dot identifier. So I'm matching it and then wrapping it again. Yep, evaluator, nice. This seems to work. This seems to work. So now I need to just do add some things to the uh, evaluator. So we need a new binary operator. This will be assign, and it returns a function that takes x and y. And what it does is it okay. Well, yeah. So we'll have okay results, whatever. But we're gonna have let's results equal, and then here we finally access the actual hash map. So that's line 22. So hash table. Yeah, okay. So if it doesn't exist, this is declaration. So if it doesn't exist, we reassign. If it does exist, if it does exist, we reassign. If it doesn't exist, we make a new entry. So hash table dot it's 1 a.m. by the way, crazy. Hash table dot find. No. If hash table dot member. I forgot what the thing was. Table and the key. Okay. Why is it reversed here? That's weird. Table and the key. So the table is variable pointers, handles even. Oh wow, so I actually got it wrong before. And the key X. Ooh. Okay, no, this is bad. This is very bad. This takes a float. Yeah, this takes a float. So I've actually just assumed that left and right. The issue with the evaluator is that if it is an expression, I mean if it is an identifier, like what do I do? Like generally what do I do? I guess I don't. Okay, so like right now I'm treating it as a binary operation. I guess that's wrong. I should really treat the whole thing as a. No, I can't though. I can't do that. What are my options? Sorry. Um. Right. So I go binary operator, unit operator, number, and identifier. Okay. My issue right now is I'm treating binary operator as a I'm treating assignment as a bounding operation. That it shouldn't be. It shouldn't be. It should be its own thing. So we'll have an identifier, which is just the identifier, and then we should have a assignment, which is of which is of string and t. So on the right we have an expression, on the left we have the identifier. And then this is just, so yeah, I call it identifier. This should be variable call, or like invoking a variable. Like what's it called when you use a variable? Variable use. What is the official term in PL design for using / calling a variable? Fetch, maybe. Lookup. Expression. Okay, so call it variable use. So if it's variable use, just string. If it's an assignment, then it's the string times t. That's fine. So in that case, I actually need to change this then. So on the left, you have the expression. If we have uh, so I guess what we need to check is if we come to an identifier, is the next token an arrow? That's probably the proper way to do it. So if like conditionally check is what's on the right a thing. The thing is though, the left has to be empty, doesn't it? As well, because you can't be having like you can't be having 5 plus 2, like 5 plus x boom boom 3. Like you can't be doing this. I guess you could actually. Should I allow this? Question is how does this even work? Because like this needs to evaluate to 3 and then be added to 5. But I can't evaluate it if I can't evaluate if I don't evaluate if I don't evaluate the right side as well. Um, like if this is this, then the right side would have to be about yeah, the right side would have to be evaluated first, then x gets assigned to, and then 5 is added to x. So it'll be our right right node left evaluation, or like right to left evaluation. I don't know. It would probably help if I was using Polish notation, if anything, but mm, yeah, okay. How do I even enforce how do I enforce that? I can't because the tokens are read left to right. No, but it's a tree. Nah, this is just a tree. So this should be okay. As long as I have a trying to imagine a tree right now. In fact, you know what? Let's pull out the drawing board paint. Thank you, paint. Okay. So increase our size here. A bit too big. Yeah. So we have our okay, well let's consider 5 plus x assign 3 plus 2, for instance. And in fact I'll do 3 times 2 for clarity. So we need to have 3 times 2 evaluate into x and then add that to 5. So our tree should ideally look something like plus. So plus is our center point. Then we have 5 on this side. I don't actually need the circles. So we got 5 on this side. And then on this side, we have the assignment operator, if I want to call it that, of assigning x, or sorry, assigning 3 times 2 to x. So this is what we want, right? Which means this, I guess, is a binary operator, but just accepts it can only it takes a string as a left input, unlike the other binary operators, which take 2 floats as inputs. But like I can still define it as a unique operator. That's fine. Like as a unique thing. So how do I parse this then? How do I parse this? It means I need to parse this first. Yeah, like just how do I know to parse this first? Um, do I actually? This is level 0. That's fine. Maybe I'm overthinking it. This should work, right? Another example, 5 plus 2 times 3. I want to have plus of 5 and 2 times 3. This works because, sorry. Well, yeah, it's fine. This works because 3 has a higher precedence. So that means we want to parse this first, this layer first. Because if we had, yeah, because then the alternative would be this, which is not correct. Um, okay. But then the question is like, what layer do we put this in then? Like, it's easy for operators like these because like the layer is just the precedence. But for the move operator or the assignment operator, it'll be dependent on position, no? Or do we say that this, because like here this has a lower precedence than this. So like we're saying that treat this like this, as opposed to, am I just is this just completely irrelevant? Because this is I guess another example that comes to mind is like the very simple 5 plus 2 minus 4. Like here, like these have the same precedence, so the order doesn't really matter. 5 minus 2 4, like that's fine because it's just left to right. Otherwise it could be minus 4 and 5 plus 2, right? So here we get 5 plus 2 minus 4. So 5 plus negative 2 is 3. 5 plus 2 is 7. Minus 4. 7 minus 4 is also 3. So like, these are equal. That's fine. So do I put assignments on the same precedence level as addition and subtraction? I can't, because I need to treat these as one expression regardless. So then do I treat it as lower precedence? But if it's lower precedence, then what I get is assignment of 5 plus x, which doesn't make sense. And the way I fix this is that this works if I can't have anything before x. Otherwise, it's really difficult. At least like in the way I'm kind of thinking of it right now. I mean, like, is this even worth it? Like 5 plus, like this is already like kind of just not nice to read. So okay, fine. So then the question is, if we want to enforce that you cannot have anything before x, so we must have nothing x store and then anything here, then that means we have this as the lowest precedence. So this is evaluated last. That's fine. Then we just have this, which is fine. And then we need to yeah. So the question is just how do we enforce this then? How do we enforce not having anything before it? A tokenizer, you could say. We could like yeah, we could parse through the tokenizer initially, do like a quick scan. Um, can I put that in the tokenizer stage for the part because the parser kind of just wants to do its thing. Because what I would have to do right now is I'm matching an ID, a left arrow. Am I tripping? No, this is fine as it is. That means that this is actually fine as it is. All I need to do is just instead of binary op, I just make this an assignment, right? Like so. Yep. With the ID string. So expression dot. No, this takes a string and a t. Uh, no, please don't do that. So it would just be like this. Assignment, don't need that. Expression. Okay, so this works, and then whoops, and then I add another case where it's left. Yes, okay, perfect. Left tokenizer.token dot identifier, like so. And for this one, expression rest equals parse L1 tokens in parse L0 rest, and this would be expression dot variable use with just the ID, a string, and then rest. So what happens here is that this will check first, but like let's say we have again like the scenario of x arrow 2 plus 3. It will say okay we see x on there, so let's say that let's make that a var use. Oh wait. Okay, yeah. So we first parse it as a variable use in our tree, but then we need to remove this, don't we? We need to remove that. Oh, where? Sorry, what's happening with left as well? I feel like I made a mistake here somewhere. Uh, the left side is meant to go before because we obviously we don't want to disregard the left side, obviously. Man, this is quite difficult. Mm, why do we not disregard the entire left side here? Binary op slash for the parentheses, we have a special case, don't we? Oops. For the parentheses, we just do this. Should I put the move up the assignment operator on the highest level instead? Yeah, I think I'm not really understanding the whole layer system properly. Let me just expand this out real quick. Um, I said 5 plus x. Okay, no, but that's illegal. So we'll just say for a simpler example, 5 plus 3 times 2. So if we run through this, we have 5 times 3, 2, and then it goes do this first. You get 6, whatever, and then 6 plus 5, 11, which is correct. How about 5 plus 3 times 2? This is a bit different. How does this work in a binary tree? Like, genuinely. That's right. The parentheses aren't actually act to the are the parentheses aren't actually added to the binary tree. They're like a special thing where it just parses through. So like the results would literally just be so we see open bracket. We're like, okay, fine. Take this expression and match it. So parcel one. Yes, like it loops back to the lowest level. I mean, FBL0 in that case, but whatever. Um, yeah. So it says, take this, treat it as its own sub-expression, and then take whatever is on the right of this, and do this. So we get 5 plus 3 is 8, and then 8 times 2 is 16, which is correct. So I guess I should actually add the thing here then. So if I get tokenizer.token dot okay, so let's do this. So if we get tokenizer.token dot identifier, right? An identifier id on tokens. Then we want to let um, yeah. Let me try to understand this here. Let expression rest equals parcel one. Uh, parcel one will return a parse result, which is just the expression on the left and then the rest of the tokens on the right. Yeah, the remaining tokens. Then we match the rest, return the expression and the rest. That's right. So what we'll do when it sees this, should we just hyperfocus here? So if when it sees 5 plus 2 times 3, what it does is it sees this, it says, okay then, go ahead and just parse these, so that it parses normally. It sees 5, which is a number. Number says, okay then, it's a number. Then so then that's the expression. It sees plus, it says, okay, look for the left and right. So then we just take that and do this. Then it says, oh, closing parentheses. Okay, if it's a but like we're matching here now. We're in this space. So okay, we've reached a parentheses closing now. Ooh, I think parse one ts t's expression rest. Huh? Why do I even have this indented? Okay. We're passing tokens. So we're passing yeah, so we're passing everything after this. Okay. So we are now past this stage and we're focusing on this. And then this should just oh god, it's hard to visualize this. It's recursive. So the C's then right. So we have a number 5. What? We have number 5. Okay, so because we're here, and then this goes out. Am I wrong? Hold on. When I call parse L1, it will just the left is an expression, the right is a token list. So it needs to start, yeah. It needs to start with this. So it calls L1. If it can't find anything in L1, it'll just go to L2, right? No. If it can't find anything in L1, the default behavior is to just return left in tokens, which is returned to this. uh, um, how much easier this would be if I just watched like a YouTube video that explained it. But let me cook. So parse L2 tokens. Okay, left in tokens. Yeah, left in tokens. So this does get returned here. I'm doing parse L1. Oh, sorry. So, okay, sorry. So we're calling parse L1, which calls parse L2, and then parse L2 calls parse R3. Okay. So yeah. So what happens here is that we've parsed this, then we're parsing 5 because it calls L1, which calls L2, which calls L3, which gets us here on tokenizer with token number, and that returns an expression, a number with the rest of the tokens. So now we've added this to our tree. Our tree is this. Okay. Then T's is returned. So L1, no, not L1, L2, since it called L3, we'll now use that in its parsed. So we parse L2 rest, like so. We find none of these, or none of these rather. So we go to this case, right? Which then means we just return the same thing. So then this returns back to where it's callee, which was parse L caller, sorry, which is parse L1, which uses is thing, and then it goes checks this list of cases. It sees, sorry, this list of cases. It sees operator plus, and it says, okay, I got plus. The left is just this right now, the tree. So I got my expression results. So we're going to parse L2 tokens, which is everything after it, the right hand side, and that will give us, well, we know that this will call parse L3, which gives us a number, and then a closing bracket afterwards. But parse L2 on tokens should return a. Okay, well let's follow it. So we call parse L2 tokens, which calls parse L3 tokens, and uses it in parse L2 parsed, but or parse L3 gives us a number again, and the tokens, so that gets returned. Use it here, doesn't find it here. Yeah. So it does come back. It comes back to here then in our plus. So we just get 2 on the right hand side. I mean, not yet, but like we're storing 2. Right? So two is our expression, and the rest is like everything from here on out. And then we're just saying, okay, we have our lefts, and we're going to put a binary operation between operator between them, like this. And then we have the rest of our tokens to parse. Then this gets returned to its caller, which was parse L. Ooh, what called it? Parse L1 called itself. Yeah, that's right. And then the caller of L1 was our bracket, right? Here. So then we have our expression, which is this, and the rest, which is everything here. And then we're going to check, does the rest have a closing parentheses? If it does, good. Then we can close this, move on to this, and the rest is quite trivial. If not, if you are missing a closing parentheses, then we have an error. Well, I mean, in this case, then the tree would look like this, but then it would expect this, but it can't find it, so we get an error. Okay, I understand that. So then the question is, can I do the same for this operator here, where I say I have my tokenizer identifier, so I have an identifier, and I want to check if the next thing. So let's. I guess I can just match it directly, can't I? Token list. The thing is, we've no way to, even if we put it here, we have no way to verify that nothing came before it. It would have to be unique. No, like no existing tree at this stage. And the only way I can think of to do this is manually, to check it manually. Yeah. Like why would we add, because it's not part of the expression. So at this point, like I feel like an abstract syntax tree is useful for, I mean, I'm definitely wrong, right? But like surely an abstract syntax tree only works for expressions, whereas I just want to have, I don't want this to be an expression. I want this to just be a kind of how do you call it? Like a procedure. Like in C++, you can do, like, okay, in C++, for instance, this is an expression where this gets broken down to 2 plus equals x5. So this becomes evaluates to 5, and this evaluates to 7, of course. Because equals is like calling 2 plus assign as x5. Like it's like this, but that only works for that. The difference is that if I do a okay, well now going to Rust, I guess. If I do a let x equals 5, this is not an expression. This does not have a tree. To my understanding, it does not make sense for this to have a tree like this, because let itself is a statement. So I think this whole part is treated as one thing, and then what happens is that the parser says, "Oh, let okay then let's just check this. If there's any type information, then look for that as well, right?" And then this is just treated as one thing, and then this is with the AST. Surely that's how it works. If it's not, then I'll be very surprised. But for now, I'll just do what makes sense, which is to me, which is we parse our tokens. We say let. Okay, so first you say if tokens dot sorry if list dot heads of tokens equals um, identifier tokenizer dot token. Should I do this or should I match it? Should we match it, right? No. I need to scan, but also no. Okay. First things first, we keep this variable use, but we remove assignment. Assignment is not that variable because now there's no there's only one case of using a variable. We don't need the distinction. Bear with me. Am I stuttering? Sorry. Uh, we need to we do need to scan then for the like we don't need to check here, like manually check if the assign operator shows up later on, because if it does, it'll just cause an error anyway, like unexpected token error, which is fine. But we do need to check if it's used initially. How do we do this? We just check the unique condition of if sorry match, right? Match tokens. In which case, should we even use a function in this case? Even I am going to use a function. So we do tokens like this. We move this, replace this with an arrow. Why is this yellow? Because we have no name. Yeah. Yep. So then we just do function and let's match it. So if we have specifically, if we have a tokenizer dot token dot identifier followed by a tokenizer. Surely I can remove these namespaces, but for now I'll just keep it. Tokenizer dot token dot um, left arrow. Nice. I was a tab I think I had to do there. Uh, Followed by the rest of the tokens. Then no, forget this. Forget this. Okay, fine. This is fine, but let's not do a function. Let's instead do this. Yeah, it's so interesting doing functional programming because like if you don't know how to do something already, like you really have to like think of like the model you want to do. But obviously, if you already know what you're doing, then it's really quick and easy. If I say, well, assuming you can remember, but if you understand it, you should remember. So if now we'll do let tokens. Can I do shadowing? Is that a thing I can do? I'm gonna assume I can do shadowing. So let tokens equal match begin match, sorry. Begin match of tokens with actually in that case I should be able to do function. What the hell? God, I was so confused. Match, yeah, match tokens. Oh, because this is the same name. Uh, so, do tokens prime, whatever. So match tokens with if it's this, then it's T's. Otherwise, it's just T's. Nothing crazy here. Then end. Probably even unnecessary, but uh, whatever. That's fine. And then yeah, I'd want like a let if statement, or like an if let. I think is what I want for that in that case. Maybe they're thinking of Rust, but okay, fine. We have this, so now we can pass this fine. Delete this. Okay, so this just says to skip the thing for now. This might even compile. Syntax error on line 83. In expression.identifier.id, because that doesn't exist. This is in the parser, line 6-7. Yeah, we can remove this now. We're not using it at all. This is the lowest layer. Parser 6-7 still. What's wrong? The constructor express one argument. That's right. Oh, we don't care what it is. We just want to know that if there is an identifier there. Left arrow belongs to the variant type calc.tokenizer.token.operator. Right, so the operator left arrow. Evaluator not exhaustive. Yeah, because there is a variable. Okay, so this should just skip it for now, which is what we want initially. But then this just returns an AST. Yeah, this should not be in the parse logic. This should be in the actual main logic. So let's go ahead and remove these here. Just leave this as is for now. In our main function, the calculate function, we have let tokens equals tokenizer to tokenize. Yeah. So after the tokenizer, we do this, and then we call the parse on this. Okay. And let's go ahead and just remove, like just for the sake of being able to test it. Let's go ahead and just remove. Okay, well this is bullshit anyway. Let's remove that. Let's remove this for now. Just comment it out. See this compiles. step by step. Parser is 6.6. Right. We've changed this back to just tokens. By the way, is this like an if-let statement? Let star parse equals parcel1 tokens. It kind of is, isn't it? Well, no, because it. No, it's not. No, it's not. I don't care. I don't care. Okay, so 5 plus 3, 8. And if I do x assign 5 plus 3, it should ignore it. It does ignore it. So it's in the tokens, but the AST ignores it, which is what I want. And then anything else, like 5 plus x, like this, should be an error. Yeah, okay, for the wrong reasons, but I'm gonna logically, I think it still works as expected. Okay, so that's good. This works good. Good. I like this. And then for the evaluator, we need to like know if we want to store it because we get the result here, and then we can store the result or we cannot store the result. So how should I go about this then? Uh, First of all, I don't want to create the variable until I'm sure that the evaluator has succeeded. So, i.e., it can be stored. Otherwise, we're just declaring a variable, and just wasting it. And that can also cause undefined behavior if people want to like try to access a variable that shouldn't exist because it failed. So we any variable creation needs to be after here in this space here, and therefore we need basically an optional type, right? An optional string, which is our identifier that we're going to store in. If it's nothing, we ignore it. If it's something, then we assign. So that should not be too difficult. We just do this ID. We do um, God, it's like I know I know how I would do this imperatively. Um, so we want to do let let. How do I define a variable in this? I don't. I define it here. Let assign assign target, we'll call it. When this is going to be a is it maybe? We have result, right? Optional? Option? Option. Okay. So string option. Let me just check this. What's the option type? Yeah. Please don't explain to me what it means. Okay. So it's none or some. Okay. Same as Rust. I mean, clearly Rust is influenced heavily by OCaml. Okay. So it'll be ref none, I think. In. Yep, that should work. And then here we don't just do this. We return tokens, but before we return tokens, we do the sneaky act of assigning. So assign target equals, how do I even assign? Show debug. Oh, that's right. The colon equals. Whoops. Colon equals sum ID. See if that works. This expression as type option ref, but an expression was expected of type string option. Huh? My bad. So ref comes afterwards as well, right? So string option ref, like so. That should work. Interesting system of mutation, I must say. That worked. Okay, so 5 plus 3, x 3, x, not going to work because I haven't closed that, but okay. And then that all works, it seems. So then I should be able to just, here, after the result, I should be able to just match assign target. I'll do begin match. If it's none, well, okay, if it's some ID, first of all, then we hash table dot, finally, we can add it to our hash table. Well, not yet, actually. We have to do if hash table dot mem variable handles and ID. Then so if it is a member, then we simply just do dinarray dot replace, was it? Set variables with the index, so hash table dot find with a table first, so variable handles and our key, set it to the result. Yep. Otherwise, I'm silly. This happens anyway. And then here, if it doesn't exist, no, if it doesn't exist. So if not, then simply create a new entry. So hash table dot what? Add. Who would have thought? So hash table dot mem add. Sorry, is it table first? Table first. Table, the key, and then the value. So table key value. Whoops, a bit more than that actually. Let's just do this. So then index. Not index. Bloody hell. So now we need to add to the dynamic array first. So dynarray dot add, I'm assuming, or push dot push. So okay, so it is always the thing first. Variables with a result. I'm actually stupid. This doesn't happen after all. Okay, this is fine for me. No need. Yeah. So do this, but if it's not in the thing yet, so we need to push it, and then we need to get the size. So at last, oh, these are different. We want at last. It's supposed to what, bro? Like, okay. Dude, like doing this in Rust will be so cathartic. Cathartic, I think. Cathartic? I don't know. Because it'll just be so much easier to do it with procedural programming and like actual objects and classes, and I mean not classes, but you know what I mean, structs. Ooh, okay, so then how do I get the size of a dyne array. Please do not do size divided by length. Okay. See, thank you. So terse, so straight to the point. I mean, I could have guessed that, but just to be sure. So dyne array dot length of variable handles. No variables. Right? Okay. So this should work. Let's just compile, see what we got. Some ID, didn't like that one apparently. Probably because I need to end, right? This match. Is it in? It's not a let statement. But also, wait, what? Lines 2 to 3, 31. Begin match with. Some ID. This pattern should not be a constructor. The expected type is string option ref. Aye, aye, aye. So I need to actually dereference it, which is fine. I wonder if I could actually do something like just do ref, like this. Maybe not. I don't know. Unbound value variable handles on line 32. Whoops. Hash table dot. What the hell? Okay. Okay, because I put it in my evaluator. We're not at my evaluator. We're in our main function now. So here. Okay. Hmm. The function dynearray at last has dynearray t applied to too many arguments. I did forget a semicolon. You were correct. Thanks for the hint. How did I mistype that? How? Like this. How would you do this in? Oh, wait, I guess in Haskell you do notation probably for that one. But goddamn. Else begin end expected. These might be unmatched. 39. What's wrong? What? 39. What, like begin end? Non-exhaustive. None. Yeah, where is none? Good question. None. We simply do nothing, right? So in this case, I want an if let. Let me see. Does OCaml have an if let like Rust does? No. Okay. Fallback. I'm trying to assume that this is valid until the compiler tells me otherwise. I think that's actually okay. Well, how do I do nothing on the none branch? Is it just like the empty semicolon parentheses? Yeah. Who would have thought? So boom, boom, boom. It works. Let's go, baby. So x boom boom boom. If I try doing something else like this, doesn't work. Yeah, I got an error there. Okay, let's go. So now the only thing left to do is to substitute the values, variables. But we have a stinky issue, which is our main function, like our main.ml, is separate from the library. So I need to kind of move all my logic into the library for the calculator, which is fine, I think. Yeah, why can't I just have more files here? Like, do I need to have it in lib, or can I just put it in bin? Because like I don't really want to like make a library. It is a standalone thing, right? Unless I want to make it modular, in which case I can have an interface for the evaluator for accepting a hash map. Um, but do I want to do that? Hell no. I do not. Not in this language. So first question, do I have to put other ML files in lib? Or can I just have everything in bin? Because otherwise, like, it's really annoying, actually. You can put everything as bin, there's no for rule. What? Are you serious? Lib tends to earn its keep quickly. You'll likely want a separate test binary that exercises your tokenizer without going through main. At that point, having a calc library calc library. Okay, I'm not using testing yet. Like at all. I guess I should use test. Um, okay then. So I'll make a calculator script, which contains the calculate function. Oh, shiza. The thing is, I need to pass then show debug um as a variable, which is fine. I think I don't see why that wouldn't be fine because I assign it here, but then that's it. Like I could easily just pass it as a variable, and it really wouldn't make a difference. Ooh, is it recursive though? No, it's not recursive. It would just mean I need to pass it into main, which isn't like, yeah, it's not a big deal. So let's go ahead and actually remove all of this from here and instead move it into a new thing here called calculator.ml. Right? And for calculate, mind you, I could just have a big global. Yeah, no, I could have a big global, never mind. I don't think I need my tokenizer here or my parser right now. Just the evaluator. Okay, so let's go ahead and just remove this as well and put it here. Okay, and then here this is unscoped, so that should be okay. Or no, I'll probably do calculator. Calculator.showDebug, which is honestly fine anyway. Looks quite clear. Let's just test that works. Line 7, unbound value let. That's right. Do I even use this here? I don't. So that should also be moved. Boom, boom. And let's put this here. Ooh, yeah. Okay. That should be good to go. Begin match calculate. Right, calculator calculate. Boom, bam. No, don't do that. Where are we? Here. Calculator, dot calculate. Show debug, where's that? In main. Oh, okay. Ooh, it's a bit dodgy actually. No, that's fine. Calculator. Unbalanced module calculator, did you mean, okay. Calculate or, if you'd be so kind. Why say none? What? Okay. Laugh it up, laugh it up. Um, yeah. Nice. Wrong one. Whoops. I meant to actually test that. Yeah, okay. Cool. So now that's been separated. I can have access to the calculator hash map here. Just need to do calculator dot. So here we go, here we go, here we go. I do actually need evaluator. Not evaluator. I did I add it twice? I did. I need parser. So parser, help me out. Okay, so parser, let's bring this back. We have variable of string. Variable is going to be layer 3 on par with number because it's just itself. So tokenizer dot token dot number. Actually, I guess I could substitute it in the parsing phase. Like, is there any reason not to? Because like it just means that I don't need to. Also, I have not used the handles thing a single time. I just realized. Um, the handles are only given. Yeah, that's kind of a waste actually, because I'm not even using the handles. But it will be useful for pointers if I choose to add those, I guess. So token.token.number. I don't know why I did number. Identifier, please. So yeah, I have a choice. I can do it here, or I can do it at the evaluator stage. And it makes sense to do it at the evaluator stage, right? In which case, here I just do okay expression dot variable ID. That is a string. I would love to make this a handle, but I don't know how I would do that. Now what? We're going to make it a handle. We are going to make it a handle. So let's do this. Here we are, right? So we're going to say if hash table dot lm mem uh, calculator dot variable handles and ID. So if it is one, then nice, we just do this, return it as it is. But we want to get the handle, so we need to fetch the ID, sorry, not the handle, which is hash table. Yeah, we're going to fetch the handle. Yeah, so we're hash table dot get, was it? Hash map. Find. Yeah, find calculator dot variable handles uh, ID. Actually, let's just make this a bit more readable. Then let handle equal this. So do this man. Handle what? Do this, sorry. Inside the brackets, please. Thank you. In. and then outside the brackets handle. Should be good. Else we want an error, so error um, error undefined variable, and we just ID. Is that it? Why not just get the uh wait, what dependency cycle? Yeah. Um I know the calculator wants to access the parser, and the parser wants to access the calculator. What do I do? Like genuinely, what can I do? Do I just separate both? No, because because parser calls a calculator. That's the issue. Okay, I think it works if I do this. So I'll take this is where we are. I'll take these and move them into a different module yet again called um variables. That should be okay. So now we need to define all these things again. So we'll just open variables. Can't be arsed. It's pretty inconsequential, I think. And then, yeah. Well, not here, but I will over there. Okay, so then, like so, like so. I swear there was another error that I'm just missing, but hold on. Okay, we don't have the circular thing. That's good. That's right. The evaluate. Okay. No. But the thing, yeah. At this point, why am I even doing handles? Why don't I just evaluate it? Uh, where am I? Expression. Because like I'm already checking if it exists, so I might as well just substitute the value in, right? Yeah. I don't really have a good reason to not. And then I can just return expression dot number. Yeah. But then like why have the handle system at all? It's just so dumb. I've goofed. I've over optimized, I think. Um okay. Fine. I will keep it. It's just weird to evaluate it the variable inside this. You know what? I want to keep it. I know it's weird, but like whatever. This is this is for learning purposes, for like learning OCaml, and clearly I'm aware of it, so it's fine. So I'll just go ahead and finish this off then with the evaluator. So we got a number for we got a variable v, let's say, which we just do, or h for handle. So we do hash table dot, not even hash table, dynamic array dot is a get. Get, it's dot get. Goddamn. V, what's V? Vector? Oh yeah. No, no. I was going to open, but no. Get calculate variables dot variables. Handle. Right. Yeah. That's it, really. That is literally it. This expression was type float, but an expression was expected of type float or error. So it would be okay. Wait, I'll probably just want this too. What the fuck? No, it's fine in this case. So 5 plus 3, 8. 5 plus x, undefined variable. Okay, I should probably change this. I don't like that. X store 5. And also evaluates to 5, which is kind of cool. And then 3 plus x. Fatal error. What the fuck? Index 1 out of bounds. I know why. I know why. Don't worry, chat. It's all fine. Before I do this, though, there was something else that I wanted to fix. Oh, that's right. Boop, bop, boop, bop. Yeah. Um, where's the error? Where's the error reported? Is it here? Yeah. Let's change this to just be like this instead, so we don't get the same thing. And then I think it's in the calculator stage. Yep, where we are adding it, not the. Well, okay, we'll do let index equal this -1 because it's the size. Oh, so this is wrong. This should be in. Okay, I am vibing with OCaml. God damn. Should compile. So 3 plus 5, just basic test. If I try to do 3 plus x, 3 plus x, error. If I try to do x stores 5, I get 5. And then if I do want to do 3 plus x again, I get 8. That's 2:26 a.m. That took us 3 hours almost. Oh, you know what? I feel enlightened. I feel yeah, yeah. So x plus x, x times x. That's 5. That's 5 times 5. I can of course do store x plus 3, and I get 8. So I can do y plus x, 13. Y just by itself, and x by itself. Yeah, that's chill. And then I can also overwrite. So x is 5, right? But I can also do 13. So now x is 13. So then if I do y plus x, which is 8 plus 13, 21. Yeah, that's it. So a few more educators. I should really set up testing on this, but like foo 3, store 2, foo 3 plus 3. Yep, that's fine. Foo bar 9, 3 times foo bar like this. That's fine. Um, even foo bar plus foo 3. That's fine. I can't do something like this as an error, and I can't do something like this. That is an error as well. It doesn't tell you why though. I could probably be more specific. Like how do I do it right now? I need the tokenizer. Here, token map. Um, huh? If it's not, oh, when is identifier? That's right. So I need to like change this to like if not is identifier, then but like I don't know if it is or not. Like for that it would have to be I'd have to look ahead, see that I have this token ahead, and then tell the person, by the way, you the reason this is an error is because that's an invalid variable thing. Um, I mean, yeah, I mean, if it was a programming language, I could do let x, and then I would know that it's thingy. But in this case, it's fine. Yeah, we're chilling. We are chilling. So anything else I want to do then? I said I want to set up testing, but there's not really any point because I can just test it myself, like right now. And I don't know how I would test more than this than what I can think of. I guess it's like just convenient, but yeah, script. Let's learn how to do tests. So how do I do tests in OCaml? For OCaml testing, the centered modern choice is alco test. Do I have to? Let test edition algo test or check int 2 plus 2 equals 4. 4 2 plus 2. What? Oh, I see. Okay. Um. Eh, I could add these, but I just can't really be bothered. Honestly, I can't be bothered. Yeah, I'll do it some other time if I can be arsed. Um, but for now, that's pretty good. I actually realized I'm not committed anything. So git add, git commit, implement, implement variables, and push. Yep. And then let's go ahead and edit the README as well. Oh boy. Yep. I'll just add some more examples, I guess. So um, x 3 um, 5 plus x. That should suffice. Boom boom. Bam bam bam. Yep. Interesting. How the font tweaks out. Okay. To see the output of both the tokenizer and parser, run the app with true as the first argument. Okay, for my understanding, the cumulative, so the only supported operations are addition, subtraction, multiplication, division, and division. You're also able to store uh, values in variables which can only contain okay These can only contain undercase and uppercase Latin letters, our English letters. Undercase. What? Lowercase. And numbers. The numbers, yeah, numbers, digits, numerical digits, and an underscore. And can only start with just lowercase letters. Yeah. To assign a variable, use the boom boom syntax. Note that this is not an operator. Is not an operator, and therefore and can only be and is only valid as special syntax before an expression, not in between, not inside one. So, like x store 3 plus 5, valid. X 3 plus x store 5, invalid. Yep. How did I miss that? My Ike's actually tweaking so much. What the I'm pressing the Ike, I swear to God. Okay. Cool. Yep. So git, whoopsie, git add, git commit, add info on variables, and push. Nice. Okay. Show, let's reload. And yeah, there it is. Very nice. You'll have to see it. Yep. So I need to do a new release now. How do I make a release? Draft a new release. Version 1.1.0. The variables update. It is now possible to define variables via special syntax. For example, this x plus 3, x3 is valid. I just writing the same thing here. X 3, that's 5, wasn't it? 3 store 3 plus x store 5 is invalid. Preview, previous tag, yep. Release notes. Okay. I think it's compiled, right? Let me just check with the trace actually on. So if I store 5, nice. I mean, the left arrow is treated as a token here, which I'm not a huge fan of. So I'm going to change that real quick. So I tokenizer. I don't want it to be. I don't want. Yeah, I don't want it to be an operator. I want it to be something else. So we got an identifier, and we've got a assignment. Obviously I could make it an operator, um, with like the highest precedence, but then it couldn't take an entire left-hand expression. It would have to be attached to the thing directly next to it, and I just can't. I struggle to implement that effectively unless I force the user to use parentheses, I guess. Hmm. Okay. There's definitely a way to do it, but for a simple calculator, I don't think it's worth it. Like I'm not sure if I can do that here. Like if I try doing 5 plus, yeah, like because the store is like to the right even. So if I try doing like 5 plus 3 store to x plus 2, I get a syntax error. So assignment, remove it from here and change it here to just token dot assignment, and in my parser, wherever that may be. Oops, to do this. In my parser, uh, no, in my calculator, right? Which is here. Yeah, here. Token dot assignment, and delete this. Should be fine. So now I can do this, and it tells me that I have specifically tokenizer dot token assignment. So it's no longer considered an operator. Perfect. And then oh, actually, also if I just do like 5 and 3, what do I get? Error cannot parse tokens. Okay. Yeah, the errors aren't actually like good, like that useful for the user because like they don't they don't know what the tokens are, but it's fine. Um, maybe I could, yeah, for OCaml I can't really be arsed. For Rust, I would definitely want to look into really good error messages. So anyway, that's fine. Then that works. And the other thing was because there was something else. I cleaning up this code. Like, do I need this or can I just do this? Because like we know it's a token, right? Although maybe the question is, should I like this? Yeah, so it works. Um, Tokens is coming from tokenizer to tokenize. I don't know what that returns, but like just from looking at it, but it's fine. It's fine. Okay. Can the same be done for other things then? Like here, well that uses it, but like for the parser, like all this stuff, can I just remove it like this? Spare me the pain. DF D2F boom, D2F boom, D2F boom. As long as it works. Yeah, it works. All right, I'll do that. Actually, before I do that, git add, git commit. Um, no longer consider as an operator. And then for these, just tokenizer.token. Just remove that. Same thing here. Yep. Even here, like, it knows it's an expression. So I don't really need this either. Return a number, return a variable. Okay. Yeah. How's that looking? Oh, don't do that. Don't push. Looks to work. And how about what the hell? Special? I've just messed this up. The tokenizer, anything there I can also simplify? Yeah, this stuff. I assume. I really like the unscoped. I mean, not unscoped, but like the just not needing to preface or like name prefix namespace. No. Okay. Here we do need to though. But like for match statements, I quite like it. And I'd like it if the same was true, honestly, for function arguments. Or maybe I'm wrong. Maybe that'd be bad. Okay, git add again. Git commit. Just clean up. Git push. I'm sure there's other ways I could clean up my code, but I think it's fine enough. Yeah. So let's attach our binaries here. Uh, okay, thanks. Programming projects. Uh, this thing. Bin. No. Build. Default. Bin. Exe. Created 2 minutes ago. Checks out. Calculator.exe. Yeah. Publish. Nice. Good work today. Good work indeed. I'm definitely proud to have this on my profile. In fact, I think at this point, I can add OCaml to my languages I've used properly. Because like for these ones, the languages I've dabbled with is for like unfinished projects, but this project is basically fully functional with a binary. So I could say I've used it properly. Obviously, not like in industry software, but I've not used anything in industry software yet. So, or like as industry, no, yeah. Um, Actually, I guess like Lua counts because I've used it for like wiki stuff. That's technically industry software. Um, anyway, yeah. So I mean, saying that, I guess my next steps are to add functions, like I said I would. Right. What's the end? Man, what 3 hours just for an MF? Yeah, I can add functions like cosine, sine. I can add constants as well, predefined constants. And in fact, for the constants, then I could make use of the capital letters, right? Like the, yeah, I mean, like, I'm not enforcing any naming scheme except for just like the first letter has to be lowercase. So I could have the constants be uppercase letters like capital PI, right? Yeah, that sounds good actually. I think I'll do that. And I'll also, for functions, how should I do functions? I'm not even entirely sure, to be honest. How do I even implement sign? Oh, just use OCaml sign. Actually, um, I like to code that from scratch. Although it would be interesting to see how they do it. Um, yeah, just looking at my calculator. Because you got different stuff, right? Er, er, er. Yeah, functions really. That's pretty much it. Functions and constants. Um, oh God. Aye, aye, aye. I mean, functions, I guess, are just the same as operators, aren't they? But just like, except they are, well, they use brackets as to take arguments. But saying that, I could not use brackets, and then it'd be easier to parse. Like, because like functional programming languages, or like I guess like Lisp, like ML style languages, I guess is what you would call them, like Haskell or Camel. They don't use parentheses around their function arguments, right? They just pass them. Um, so I could do that for sure. Yeah, maybe I'll do that then. So then like I don't have to faff around with parsing the arguments otherwise. Not that it'd be difficult anyway. Like I just match the identifier to the function, and then if it's recognized as a function, then it just parses the contents. But if I do it without the parentheses, then it's just it's even easier. I guess it's just like a different way, a different style. I don't even know if it's necessarily easier to like implement. They feel kind of both pretty easy. Um, already. I mean, so yeah, I can add functions. I think quite easily. The only question is like, do I expand them to a binary tree, right? Because that would be lazy evaluation, or do I evaluate them on the call site? By which I mean, it doesn't matter anyway because either way it's going to get because like in for my calculator they're one line expressions, so it doesn't matter anyway. It'd be different if I let people define their own variables. Sorry, their own functions. And how would I do that? How would I do that? I feel like we defined the whole system kind of. Uh, do I want to do that really? I don't think I want to do that. I'll think about it. But anyway, good session today. 3 hours, but definitely learned a lot. Feeling a lot more confident with OCaml now. Honestly, this has been a great project, and I just really look forward to doing Rust. So yeah, subscribe for more videos.